In this video, we're going to talk about how to calculate the correlation coefficient between two variables. But before we do that, let's talk about what the correlation coefficient tells us. So let's say we have a straight line and we have points on the line. The correlation coefficient will be +1 for this situation because all the points are on a line and the line has a positive slope. Let's say this is x and this is y. It's a positive correlation because as x increases, y increases. There is a direct relationship between x and y. Now here's another scenario. Here we have points on the line, but notice the line is going down. And so the correlation coefficient will be equal to -1. As x increases, y decreases. And so in that case, we have an inverse relationship. Now in this example, the points are not necessarily on the line, but they're close to it. And so these points, they have somewhat of a linear relationship, but not exactly 1. So in this case, r is going to be somewhere between 0 and 1. It's positive because this line is increasing. It has a positive slope, but it's not exactly 1. If we were to put a number to it, it might be 0.8 or something. Whereas let's say if you have a similar line, but let's say the points are more scattered about that line, the r value will be less. It might be 0.7 or 0.6. It could be completely different, but it's somewhere between 0 and 1. But the point is this though. The closer that the points are next to the line, r is going to be closer to 1. These points, they're further away from the line, so r is going to be closer to 0 than 1 relative to this number. Now sometimes there won't be any correlation. Let's say if you have just random points everywhere. In this case, r could be very close to 0 for a situation like that when there's no apparent correlation. So the correlation coefficient really tells us the strength of the linear relationship between two variables. If these two variables have no linear relationship, r is going to be close to 0. If there is a strong linear relationship, r is going to be close to either +1 or -1, depending on the slope of the line. Now let's take a minute and calculate the correlation coefficient. So we're going to make a table containing the columns x, y, and then the product of xy, and then x squared, followed by y squared. So for x, we have the numbers 1, 2, 3, 4, 5, and 6. So let's extend this a bit. Alright, now let's fill in this table. So next, let's put the y values, which are 2, 4, 7, 9, 12, 14. Moving on to the next column, we need to multiply x and y. So 1 times 2, that's going to be 2. And then if we multiply 2 and 4, we're going to get 8. Next, we're going to multiply 3 and 7, which is 21. and then 4 times 9, that's 36. 5 times 12 is 60, and then 6 times 14. 6 times 10 is 60, 6 times 4 is 24. When you add 60 and 24, that gives you 84. Now moving on to the next column, x squared. So we're going to square the values that we see in the x column. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Now for y squared, all we're going to do is square the values in the y column. So 2 squared is 4, 4 squared is 16, 7 squared is 49, 9 squared is 81, 12 squared is 144, and 14 squared is 196. Now our next step is to sum up each column. So if we take the sum of the x values, it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's going to be 21. Let me put this in a different color. Now let's take the sum of the y values. 2 plus 4 plus 7 plus 9 plus 12 plus 14. So that gives us a sum of 48. Now we need to determine the sum of the product of x and y. So 2 plus 8 plus 21 plus 36 plus 60 plus 84. So that's going to give us 211. Now the sum of the x squared values, 1 plus 4 plus 9 plus 16 plus 25 plus 36. So that's going to be 91. And then the sum of the y squared values, 4 plus 16, 49, 81, 144, and then plus 196. So that's going to be 490. So this is the sum of the x values. 48 is the sum of the y values. And 211, that's the sum of xy. 91 is the sum of x squared, and 490 is the sum of y squared. So once we have those numbers in red, we can now plug in the information into the formula to get the answer we need. So I'm going to delete everything up to there. And here's the formula that we need. So the correlation coefficient R, which in some equations is represented by the Greek symbol rho, it's equal to n times the sum of xy minus the sum of x times the sum of y divided by the square root, and inside the square root it's going to be n times the sum of the x squared values minus the sum of x values, but we're going to square that. So be careful with that difference. And then it's going to be n times the sum of the y squared values minus the sum of the y values and then squared. So let's plug in everything into that formula. So it's going to be n, well, we need to know what n is. And if you recall, there were 6 x values, 1, 2, 3, 4, 5, 6. So n is the number of values that we have in one single column. So that's 6 in this example. And then times the sum of xy, which is 211, minus the sum of the x values, so that's 21. And then the sum of the y values, that's 48. So at this point, we just gotta plug everything into this formula. And then it's going to be n times the sum of the x squared values, which is 91, minus the sum of the x values squared. So that's 21 squared. Then it's going to be n times the sum of the y squared values, which is 490, and then minus the sum of y, which is 48 but squared. So that's what we have so far in this example. Now let's plug everything in. So we can get rid of these numbers. Six times 211 is 1266. And 21 times 48, that's 1008. Now, 6 times 91, that is 546. 21 squared is 441. Now, 6 times 490 is 2940. And then 48 squared, that's 2304. Now let's subtract 1266 by 1008. So that's 258. And then we have 546 minus 441, which is 105. And then 2940 minus 2304, that's 636. So far we have r is equal to 258 divided by the square root. And now let's multiply those two numbers. So 105 times 636, that's 66,780. So if we take 258 and divide it by the square root of 66,780, we get an r value of 0.998. So this r value is very high. This indicates that there is a very strong linear relationship between the x and y variables that we have in this problem. And the fact that it's positive tells us that the slope is positive, that there's a direct relationship between x and y. As x increases, y increases. So that's basically it for this video. Now you know how to calculate the correlation coefficient between two variables.